Hey, if you'd like to earn CEUs for this webinar, join the 𝗓𝗄𝗄𝗃𝗃 community at the link in the description below. Now, on to the show.
Hello and a warm welcome to everyone. We would like to wish everyone a good morning, a good afternoon, or a good evening, depending on where you are in the world. My name is Samantha, and I'm from 𝗓𝗄𝗄𝗃𝗃. And here at 𝗓𝗄𝗄𝗃𝗃, it is our mission to support the EHS professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I'd like to extend a huge thank you to all of our dedicated safety professionals for the great work they do on a daily basis in keeping our workplaces safe. Just a reminder, this webinar is being recorded and we will send out a link to the recording to everyone in a few days. This webinar is for you, so let's keep it interactive. Make sure you get your questions or your comments into the Q&A and we will get to them at the end of this presentation. Today, we are proud to present the right way to choose high heat PPE. This 𝗓𝗄𝗄𝗃𝗃 webinar has been made possible today by Chicago Protective Apparel, a preferred manufacturer member of the AD Safety Network. AD, together we win. It is now my pleasure to introduce to you today's presenter, 𝗤𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 and how to help equip you with the right knowledge to make sure that you're informed to make decisions about high heat PPE selection. I'm very excited to have you all sit back, relax, and enjoy this presentation. With that, Marianne, let's jump into it.
Good morning, good evening, good afternoon. I saw the attendance list, or at least the early registrations, and I think there were 8, 9, 10 different countries. So wherever you are, thanks for joining today. So the title of our discussion is The Right Way to Choose High Heat PPE, but I'm going to start right from the beginning by saying there isn't really one right way. And so what I want to share with you today is just some of the possible ways to make choices around high heat PPE and some of the things to think about. And it is one of the sort of biggest challenges of addressing high heat hazards is that there isn't one clear answer. It's different from some other type of hazards where there's very clear recommendations or very clear guidelines. High heat hazards we don't have the luxury of that. So you really have to, more than anything, ask a lot of questions. And then as you work your way through the questions to be asked, you can develop some recommendations or some solutions as a result of the information that you glean. So the next half hour, 45 minutes is really going to be about thinking about the kinds of questions to ask yourself as you analyze a high heat hazard. I had 2 goals that I hope you share for today, which is just learning to identify high heat hazards and then becoming more confident choosing high heat protective apparel PPE for your team. I do want to start though first by differentiating between high heat hazards and heat stress. I have seen more and more discussions or conflating of high heat hazards with heat stress, especially because there is so much increased activity around heat stress. So we're not talking about heat stress today. And just to make real clear the difference there, I mean, heat stress is one of the things that happens as part of high heat hazards, but we're not talking about heat stress the way that OSHA is talking about it so much recently, and of course many other safety organizations as well. So high heat hazards are intrinsic to the task that's being performed, and they can't be separated from the heat source. So you're doing what a lot of people call hot work, which is different than a heat stress where the activity that you may be engaged in might have nothing to do with heat. The work environment in a high heat hazard is not necessarily the primary contributor. You might be working outdoors in winter, but you're doing work that has a heat source, like welding, for example. Whereas in a heat stress, of course, the environment is 100% a contributing factor to that injury. And then the main hazard that ties to high heat work is the risk of burns, first, second, third degree burns on your skin, on your eyes. Whereas heat stress, the focus is on dehydration, exhaustion, stroke, etc. And then ultimately, you know, the solutions are different. So for a high heat hazard, really the only thing that you can do besides engineering out the hazard, and that is always the best option, is to wear appropriate PPE. Heat stress is different, of course. Hydration, limiting time to exposure, et cetera. So just to level set, so we're all on the same page, when we're talking about high heat hazards, I'm talking about work that is intrinsically, by definition, hot work. And for me personally, again, there's not really clear definitions around this, but for me personally, I'm typically thinking minimum 200 Fahrenheit, 1,000 or 100 Celsius-ish. And at Chicago Protective Apparel, we're primarily addressing high heat hazards that are 500-600 Fahrenheit and above. So my friends at Encyclopedia Britannica do a much better job than I do of defining the types of heat transfer. So I'm going to play a short video here just to cover thermal transfer, the types of heat transfer, because it helps to situate us for the different kinds of heat that exist and why therefore we have to have PPE solutions differentiated for each type.
Heat is energy transferred from one object to another as the result of a difference in temperature. Heat is the actual energy, and temperature is a measure of the amount of energy. If two objects have different temperatures and are brought together, heat energy is transferred. Heat flows from the hotter object to the colder. That's why water that was once cool is brought to boiling, as heat from the flame is transferred to the cooler pot, and from the pot to the water, and from the water to the eggs. In most cases, the transfer of heat means that the cooler object is warmed while the warmer object cools as energy is transferred. Inside a refrigerator, the hot eggs will warm the storage container, but as energy is transferred from the eggs to the container and to the cooler surroundings, both the eggs and the container will cool. Sometimes a substance can absorb heat without an increase in temperature. This happens if the substance changes its physical state, such as when ice melts or when a liquid turns into a gas, such as this boiling water. There are three ways to transfer heat. The first is conduction, which occurs in solids or fluids that are at rest, such as this metal bar. The second form of heat transfer is convection, which occurs in liquids or gases that are in motion. And the third form of heat transfer is radiation, which takes place with no material carrier. For example, infrared radiation is responsible for the warm year-round growing conditions in a greenhouse. Heat is most commonly measured in calories, which are also called gram calories, and British thermal units, or BTUs. A calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius at a pressure of 1 atmosphere. A British thermal unit is the amount of energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. 1 BTU equals about 252 calories. Most people think of the word calorie in the context of calories contained in food or of calories burned through exercise. That calorie is the large calorie, which is equal to 1,000 gram calories. Heat.
All right, so radiant, convective, and conductive heat. For purposes of our time together today, I'm focusing primarily on conduction and radiation. So just to simplify, when you touch something hot or when you are working close to a heat source, high enough heat that it's impacting your ability to perform your job. I'm not going to spend much time on convection today. There are in the United States and in Europe various standards that are relevant to heat in general. And but for today's purpose, I'm not going to focus on NFPA 70E or 2112, the arc flash and flash fire. Today, we're looking more at that thermal heat and standards related to thermal heat. And so primarily in the United States, it's 𝗵-1002, ASTM 𝗵-1002, and the testing methodology that relates to that, which is F955. So you will encounter that a lot, and that's a molten, you should think of that as a molten splash standard. And then I just wanted to touch on also EN 407. So 407 is tied specifically to hand protection. It does not apply to apparel, and we don't have an exact equivalent in the apparel space the way that there is in hand protection. Just to call out sort of the differences of when we think about different events that have either a flame or a heat hazard. There's the duration of event to look at. How long does it last? Is this, for example, an arc flash event is a millisecond, but an extremely high temperature, as high as 35,000 degrees Fahrenheit. For the thermal risks that we're talking about today, they are longer risks. They may be part of the actual task to be performed. So it could be 2-3 seconds, as long as 15, 20, 30 minutes that you're trying to find a solution, a PPE solution to address. So a wide range or variability on the time of exposure, and then also a very wide range of actual temperatures of the event. It depends on the work that's being done. That is less the case for an arc flash event, for example, but in molten metal splash, for example, your temperature is going to be tied to either to the furnace temperature or to and that of course is usually tied to the temperature that's needed to make the solid substance molten. So that it's a very wide range for metals, also true in the pulp and paper environment, different temperature ranges. So you want to look at the duration of the event and the temperature that is typically involved. Just to go a little bit deeper on the molten splash, molten metal specifically. So a lot of hot work in the US anyway is tied to molten metal in some capacity, metalworking, whether it's casting or foundry environments, or casting at foundry environments. So the F955 testing that is part of this ASTM F1002, it lays out the requirements for how we will evaluate a molten metal splash. And again, you're looking at a few things, including temperature, and then the output of the testing result gives you numbers that are then placed on what's called the Stowell curve. And we're looking for the output to fall below that curve, which you can see represented here in this middle image as that red line that's running through the image there. So you literally take as a test method a ladle of the molten substance that you're trying to test a fabric or solution for. At there's a panel that is placed at a 70-degree angle, and then the substance is poured onto that, and then there are thermocouples behind that panel that are sensing the results of that pour and giving you output to know whether the results would fall below or above that Stowell curve. And then the output of this testing tells you the long and the short of it is the time the time of heat transfer, to get to a theoretical second-degree burn. We know that when the body has more than 50% exposure to a burn above a second-degree burn, there is a higher chance of a fatality. So your chances of survival are considerably better if you stay below that Stowell curve. And so that's where the F955 testing is extraordinarily valuable, of course. It is a molten metal test primarily, but there are other industries where there is not a clear standard yet where they use the same. So for example, for smelting in the pulp and paper environment, they also look for solutions tied to a pass-fail on an F955 because the hazard is similar, although not identical to molten splash. So once we have some information, we know a little bit about the kind of heat. We know a little bit about what applicable standards might be appropriate to the work environment, then we ask ourselves, all right, so what kind of PPE might we deploy to address the kinds of hazards that we've identified in those first couple of steps of looking at the hazard. There are primarily, we think of clothing, apparel PPE as primary protective clothing or secondary protective clothing. And it's a fairly straightforward distinction. Primary is typically worn closer to the hazard. It's the first line of defense against molten metal splash and radiant heat. And frequently, historically, we think of aluminized apparel as being the primary protective solution. However, there are now, and there have been for some time, some technical fabrics that perform in many cases as well or even better than aluminized fabrics. So that very clear distinction between primary and secondary can be blurred sometimes, but typically primary is when you're working very close to the hazard and you have the highest level of protection. Secondary clothing might be layered in a specific layering in order to achieve a certain type of protection, but can be worn alone also in cases where there's brief or intermittent exposure, or on workers who work in a facility where hot work is happening, but they themselves are not engaged in that hot work. So here we're talking more FR cotton as a solution and other inherently FR fabrics, but that don't have that aluminization on them. So it's just clothing, really. The former owner of this company used to say, hey, if you wear clothes, you're halfway there in terms of being an expert on high heat PPE. And he wasn't entirely wrong. If you wear shirts and pants and jackets and coats and sleeves and leggings, you already know a lot about solutions for high heat PPE. The differentiator for what Chicago Protective does anyway is take those garments that we already know protect the body and make them with highly technical fabrics that provide a high level of protection, much higher than if you were just walking around in your denim jeans. So on the left, again, you'll see examples of a primary protection. It's an aluminized, a full suit. The gentleman on the left is probably doing some pretty hot work. Gloves, spats, etc. On the right are some of the technical fabrics that we work with a lot at Chicago Protective. On the bottom, FR cotton, very common, has been in use for many decades, is still the primary, let me not use that word, is still the main solution in a lot of foundry environments, and even the very largest ones, because it is affordable, washable, relatively comfortable, but it certainly cannot sustain extreme hazards that would require either the garments on the left or either of the garments that you see a little bit above there. On the left is a garment made from a really fantastic fabric called Marlin Plus, which has wool of all things as one of the main fibers that provides protection. And then on the right is a Carbon X fabric called Repel, and we'll get into a little bit more about fibers and fabrics in the next slide. Okay, so you need a coat, or you need a jacket, pants, but what do you make them out of? And this is where really all the magic happens in high heat protection. So fabrics matter, and how we get from to a fabric is we got to start at the fiber level. So fibers are spun into yarns, and those are woven into fabrics. And interestingly, there's really only a few, relatively small number of core fibers that make up the vast majority of high hazard PPE fabrics. So our supplier partners take a variety of different fibers and weave them into fabrics, taking the benefits of different kinds of fibers to end up in a blended fabric with any number of attributes depending on which fibers they choose to weave. So these are some of the core fibers that are high performance and that work best for, in our experience and in our customers' experience, for high heat hazards. Aramid fibers, that's a generic name. You might think of aramids or para-aramids as Kevlar or Twaron. You probably also have heard of Nomex. So those are, in the case of a para-aramid, extraordinarily strong while being flexible, which is an interesting combination. And then in meta-aramids, high heat resistance, and it's also a flexible. One of the nice things about a meta-aramid is that it's a white fiber, so it doesn't have a sort of the yellow tint that Kevlar tends to have. There are carbon fibers. We do a lot of work with Carbonex. And what a carbon fiber is essentially a pre-burned fiber. It's already burned. It's almost like charcoal or coal. You can't burn it. It won't combust because it's been pre-burned. It's a very, it's a strong but not particularly flexible fiber. So the manufacturers of Carbonex fabrics take that carbon fiber and combine it with other fibers to make a wearable and comfortable, because if it was just carbon, it would not be either wearable or comfortable. On the bottom, nylon, monocrylic, wool. Again, those ones are in garments that probably all of us are wearing on this call today, but they can be combined, and they are combined with some of the fibers that you're seeing above to take the benefits and strengths of those high performance fibers and combine them with something that is much more wearable, comfortable, but also durable and flexible. Okay, so we have fibers. We choose a bunch of fibers, 3, 4, 5, depending. Then we got to take those fibers and weave them into a finished fabric. There's some magic that can happen here too. The way that we weave impacts the performance of the fabric. So you've got some examples of some weaves here: plain weave, twill weave, satin weave. And the tightness of that weave can be leveraged to get better performance out of it, or the looseness. A loosely woven fabric incorporates air, and that can provide higher thermal protection. Likewise, a very tightly woven fabric may help with avoiding combustion, and it might also be more comfortable for the wearer. So we work with our supplier partners on fabric construction, and they of course are the experts on that, to understand how we take a combination of fibers, but also looking to different weaves to figure out how to create the best overall performance and experience for the wearer. So not just that thermal protection, although that of course is the primary consideration, but also how do we make a garment that is wearable? Because the bottom line is, if the worker isn't going to wear that fabric consistently, reliably, the way that the garment must be worn or should be worn, then it's not really of any value. So what I just sort of want you to have as a takeaway is that the fibers matter, of course, primarily, and you probably hear all the time Kevlar, Nomex, et cetera, thrown around, but they don't. That is only part of the equation. The way that they're combined together and woven is very much part of the user experience and the protective benefits, therefore. All right, so now we're going to get into the meat of how we choose a PPE. And as I said at the beginning, I'm not going to tell you, even getting through all this list, I'm not going to tell you why, because there isn't one single answer. Each hazard has to be evaluated on its own, not just the hazard itself, but the environment that it's in, how the worker moves, et cetera. So here are some of the questions that I think of. These are certainly not ones I've only come up with on my own. It's from the 110 years of experience that we have here at CPA, and my competitors and what they've learned, and our vendor partners and what they've learned. And then, of course, most importantly, feedback from workers in the field who are actually doing the tasks and share their experience and expertise with us. So I always start with, what's the average working temperature? Sometimes people know, a lot of times people know what the average working temperature is for the task that they're performing. So that helps you to situate generally what kind of fabrics you might be using to address a hazard. You do want to also know, though, what's the maximum temperature that might be reached, right? We want to make sure that a solution that we develop is prepared to address some of those outlier events that might occur. So average working temperature, but also important to know what the maximum temperature might be. And then how often does that max temperature get reached? Is that once a year because something not planned happened, or is that once an hour? Is it once every 3 minutes? That will impact how we choose a solution. And then also, how long does that exposure at the high temperature last? Is it very brief, a second or less than a second, or might it be several seconds or minutes that would have an impact on choosing a solution? Going back to the beginning, does the wearer touch the item or just work near the heat? That's the difference between that contact heat and radiant heat. You will need to have different fibers in your PPE garment if you are touching the item than if you are just working near it. And if you're working near it, you might be looking more at an aluminized solution, because that aluminization pushes that radiant heat away from the wearer. But again, for both of those, as part of that analysis, how long is the usual exposure time? Because a solution that performs well for 3 seconds may not perform well for an exposure of 3 minutes. Is the wearer picking something up or holding something? And if they are, how heavy is that object? I mean, that's something that comes up a lot in casting and grinding environments. How heavy is that object? And that ties to back to the discussion of air. So when you the air that's trapped in layers of fabric or in the weave of the fabric itself, that has a naturally insulating, thermally insulating property. If you smash that item, the layers of the fabric or the fibers of the fabric together, you're pushing, because you're carrying something heavy, you're pushing that air out and you're losing the benefit of that thermal protection. So a heavier object, and you've probably all experienced this, just, I don't know, taking a pizza out of an oven or taking that casserole versus just the light pizza. That heavier object, you feel that heat transferred much faster than a light object. So it's important to know how heavy is the object and how long is the person holding it. And then the best third question there would be, and how often is that happening throughout the day? Because sometimes we develop solutions, whether it's gloves or apparel, that work great for that 3 minutes of activity. But if the 3 minutes then extends to 3 minutes being done every 10 minutes, so that it happens hundreds of times throughout the day, those fabrics may not perform as well, or you may need additional protection for those longer duration activities. Then we get thrown a loop if there is moisture or splash involved. So it's one thing to address that thermal hazard, the radiant heat, but if there's moisture involved, then we have other risks that can come into play. Steam that gets released as part of hot moisture, and then, of course, just the penetration of that moisture to the wearer's skin, to your hands, to your body. So it's important to know if there's moisture or splash. If it's splash, what's the substance? Is it water, or are we talking about a molten metal splash, or something like a chemical, a caustic substance? In those situations, you have to have a solution that addresses not just the high heat, but of course also the caustic substance. And then helpful to know if there's other kinds of hazards. So sure, we're talking about thermal, but are there other things in play? Is there a risk of cut or abrasion, because there are some thermal fabrics that perform beautifully for that high heat hazard, but they are not at all abrasion resistant or cut resistant. So if you're in that situation, then what might have seemed like the best solution for that thermal hazard becomes less appealing because it is not abrasion or cut resistant. And then the question that I was taught to ask first, and it's still the best question as far as I'm concerned, is what is being used now? If you're in an environment, what are you using now, and what's working about it? What's not working about it? What's not working about it really is where we find opportunity to go deeper at developing better solutions for folks who do high heat work. So you always want to know, what are you using now, and how's that working for you? And then it's helpful to know, and now we're going to get a little bit back into the sort of heat stress versus high heat work. What are the ambient air conditions in the facility? Is that environmental heat stress an issue? As you can imagine, when you're doing hot work, there's also the attendant risk of heat stress. How big of an issue is that? I've been in foundries, they're gigantic facilities where even in winter, the doors are open, huge dock doors, et cetera, open. That can help with airflow and create a cooler environment. But then there's also, welders in building submarines in very tight spaces. They are going to have to deal with both that immediate heat risk from the work that they're doing, but also the heat stress of the environment that they're working in. So that's a more complex hazard, and good to know that as you think about best solutions for that particular environment. I'm going to pivot just for a minute, if you'll indulge me, to tell you a little bit about Chicago Protective Apparel as we wrap up here. So CPA we're in our 111th year in business. So we've learned a few things about high hazard PPE. We still have a lot to learn. I think it's incredibly important to approach high heat hazards with humility and with a desire to learn, because every hazard is different. But we do have 111 years in business, so we do know a little bit that we can share with you. Our focus is on fit and feel and function. So as I said earlier, no good to anybody if you have a solution that nobody wants to wear. You won't get compliance, you won't have safer workers. So we focus on taking the best fabric solutions and technical solutions and making sure that they are wearable. We manufacture in the US. The image that you're seeing on the right there is our factory, which is right behind my wall here. We have 75 plus sewers here. We do also manufacture in Mexico, where we do our higher run. That's primarily FR cottons and uniform type work. Almost all of our high heat hazard solutions are made here, about 10 feet away from me in Skokie, which is a suburb just north of Chicago. We have quick turnaround time on custom apparel, three weeks lead time typically. And we are happy to work with you, our sellers, our inside sales team, me as product director, to develop a custom solution to address your specific hazard if you haven't been able to find something that works for you. We are certified to manufacture to NFPA 2112 and 70E, and we're also ISO 9001 compliant for quality management. That's an extraordinarily important part of making sure that we're delivering the best products to you. And I highly advise that you only work with folks who do have that 9001 compliance. And that, friends, is it for my part of the presentation. This will be shared with you, and there are additional resources, including, I think, a pretty great we call it our Foundry brochure, but it's really a high heat hazard solution. So that is linked here at this web landing page for you to have more resources. And then, of course, I'm happy to make myself available to you for additional help if needed.
Fantastic, Marianne. That was a ton of great information in such a short period of time. So I'd encourage anybody, if you have any questions or comments, now's the time to let us know there in the Q&A. If you need any additional resources or support that you would like help with, please let us know in the chat. And Marianne and I will make sure that you get the proper attention. So Marianne, as we get ready for for people to ask their questions. Is there anything that you want our audience to keep top of mind or take away from today?
I just really think that although we tricked you by telling you we were going to tell you how to choose high heat PPE, I think the most important takeaway is to know that there isn't a clear solution in every case. It's very much a case-by-case analysis. So you want to leverage the expertise of a company like mine or my competitors. We all really work with sort of the same, mostly the same vendors for fabric solutions. Fabric is at the core of best solutions for high heat. And so it's fine that you don't know necessarily. If you're not sure, that's true for me too. I can't tell you, if you give me, just two bullet points, I can't necessarily tell you what's the best solution. You do have to ask more questions. So my goal for our time today was really more to give you some idea of the kind of questions and to help you feel more comfortable not knowing, because it's really in that not knowing that you got to push a little bit deeper and develop some guidelines around how to choose a solution. And then really it often comes to testing options in the field. So a comfort level with not knowing is really important. You need that humility when you're approaching a high heat hazard, which is an extreme and dangerous hazard.
Absolutely. I think one of the most asked questions, especially when it comes to heat, is how often should high heat PPE be inspected or replaced?
Yeah, so there are not clear guidelines, but I think it's a good idea to do what is part of the 70E arc flash guidelines, which is inspect it before every single wear. So you're looking for tears, holes, abrasion that has worn through. And then, I mean, high heat apparel, especially, for example, an aluminized apparel, which you can't wash, you certainly can't industrial launder. You would just wipe it down with a wet cloth. It's harder to maintain. It can be very hard to maintain. The fibers, the one good thing about it is the fibers themselves are extraordinarily durable, right? That's the whole point of the solution. So some solutions last a long time. It could be months of work. If it's not worn daily, it might even be 5, 6, 7 months. But then, I have also worked with end users who are wearing a really highly protective high heat glove, and they go through a pair every 30 minutes. So again, I wish I could, button it up and give you a clear answer, but it's very specific to the hazard and the environment. But I think the best approach is to always inspect the garment before you wear it, before every single use, to identify areas that there might have been some tears or imperfections, and then get that replaced as soon as possible if that happens.
Absolutely. Now, I know this is a big one with PPE, regardless of whether it's for high heat, but especially for high heat, comfort is a big thing. Comfortability, easeability, movement, it's a big thing. So sometimes alterations do need to be made. Is that possible? How does that work? At what point does an alteration now make the garment or the PPE no longer FR?
Yeah, so it is rarely a good idea for the end user or the end user employer to make repairs and alterations, as tempting as it might be, mostly just because you probably don't have what you need on hand. So, for example, our garments, yes, it's technical fabric, but it's also technical threads, Kevlar threads. Everything that leaves this building is sewn with either a Kevlar or a Nomex thread. So if you were to go into your grandma's sewing kit and pull out just thread that you might darn your socks with, you will not be maintaining the integrity of that original integrity of that garment. So unfortunately, it's not impossible, and there are some of my supplier partners have really cool solutions. One of them is Marina Textile, that has that's primarily a molten metal splash solution, or at least the ones that we sell. They have little iron-on patch kits that you can just apply over a hole that might have been caused by molten metal splash. So there are some limited solutions that are available for the end user to make repairs on site, but typically you would need to reach out to your supplier partner and either replace the garment or talk to them about making repairs.
Iron-on patch kits is an interesting solution because I know sometimes with FR shirts and things like that, the label is stamped on the inside, and that's can be quite itchy, but there's nothing you can do about it. I'm wondering if an iron-on patch would alleviate the irritation.
Yeah, so some of us have moved. We're in transition. Some of our products now we don't have a traditional hang tag label. We have a heat applied, a heat transfer. I and my competitors, I think we're all working towards addressing that. I mean, something that's just a factor in the industrial PPE space in general is that there's been a relatively low expectation for comfort. Some of that is because the garments were never worn alone, right? They were always, at least you had one layer, if not two layers underneath. So there never was a very high expectation of comfort. But fortunately, as all of us PPE suppliers compete for everybody's attention, one of the things that we're looking at more and more is increasing that comfort level and making the garments more wearable. So yes, even for something as simple as that 𝗔𝗽𝗃𝗃 label, many of us have moved towards a heat applied version of that, and same likewise for repair options.
Fantastic. Well, our last question here, they would like to know, is wool used in your FR PPE?
It is. So some of the, almost all of our high heat gloves have a wool liner for its thermal properties. And then I think I've already mentioned fabrics from a company called Marina Textile that we work with quite a bit, that has they have a high percentage of wool fibers in most of the fabrics that we use. Wool is a little bit of a magical fabric. It's inherent fiber. It's inherently FR. And so our supplier partners who work with wool fibers leverage that inherently FR. Also some shedding capability that it has for shedding molten splash, for example. Yes, so wool is it's better than cotton, for example. It performs more highly than cotton than that you see in many FR products. Yeah. So and now there's a great deal of work being done around how we might be able to recycle FR fabrics that have some wool content or cotton content, and then even there's work being done around recycling aramid fibers that are in FR fabrics.
Fantastic. Well, Marianne, again, I want to give you a huge thank you for all of the wonderful information. I think it's so important to know what's going on when you're in a high heat space. And I think we should be working more towards having these conversations so that we can get towards an expected level of comfort with FR PPE.
Absolutely.
So a huge thank you to you, a huge thank you to Chicago Protective Apparel for allowing you to be here, as well as AD Safety Network. And I want to thank all of the dedicated safety professionals and the audience, because without you, none of this would be possible. So again, look out for your email next week with the slides, as well as a copy of this presentation. And Marianne, if you want to send us any more information for our end users here, that would be great. And please reach out to Chicago Protective Apparel if you have any other questions, and we will get you connected. So as always, thanks again. Take care. Stay safe. Bye, everyone.